All right, our last two types of erosion that we're going to look at are erosion by ice, which is done by glaciers, and erosion by gravity, which we also call mass movements. Glaciers are basically giant rivers of ice, and they move downhill just like a river, and they change Earth's surface as they move. They're going to scrape large sections of land, they'll pluck rocks, and push piles of debris over great distances. And you can see from the picture there on the right, they even polish the stones as they move. Here is a picture of one of the glaciers that's in Alaska, and you can see it looks just like a river, only it's ice flowing downhill. A lot of times we find them in high mountain areas because that's where you get enough snowpack to create the thick ice, and then gravity causes it to move downhill. It is very slow. You can't actually see it moving. Now, if it does empty into a body of water, you can see huge chunks break off, which is a process called calving. Those glaciers that are in mountain areas are called valley or alpine glaciers. There are 3 in this picture here, and you can see kind of the valleys that they've carved out in this mountain area. We find these in the Himalayas and the Alps and the Andes. These particular ones in this picture here are taken in Alaska. Continental glaciers are ice sheets that cover very large areas like Antarctica, where you don't have mountain areas, but you still have enough snowpack to create the ice, and it stays cold enough year-round that we don't see that melting. During the last ice age, continental glaciers covered much of the northern part of the United States. When glaciers move downhill, the first thing they do is they're going to pluck rocks and carry them away. So in this diagram, you can see the rocks that are plucked get stuck in the ice, and as the ice moves downhill, the rocks are carried away as well. Those rocks that are stuck in the bottom of the ice are going to scrape the ground underneath so it can smooth and polish the rock, and we get the striations that we see here. Some of the landforms that are formed by glacial erosion, the first one is the Glacial Trough. It forms a U-shaped valley, so you can see this main valley here from the glacier. If you have a tributary glacier, you can get what is called a hanging valley. See how this glacier hangs above the main trough, but it too is U-shaped. Very different from a river valley, which are V-shaped. Other landforms, the arates or the sharp ridges that are formed. If you have several arates that come together at a point, that's called a horn. We see a lot of these in the Alps, like the Matterhorn in Switzerland. Now, glacial deposition, so all of the sediments that were eroded or carried away by the glacier are deposited in a new location. The material, that unconsolidated sediments that have been carried from wherever the glacier has moved, is called till. And as the glacier melts, those sediments are just dropped where they are. When you get ridges of till, like you see in this picture here, basically like a big pile, that is called moraine. Now, depending on where it is in relation to the glacier, there's 3 different types of moraine. Lateral moraine is what forms on the side, so that's all the stark material that you see here as the glacier moves downhill. We have medial moraine, and you'll see this in the next slide. When 2 smaller glaciers combine, you get that ridge of till in between the 2. It almost forms stripes in the glacier. And then terminal is what forms out front. So this is where most of our till is going to be. So here's that picture of medial moraine. You see you've got 2 glaciers that come together, so this stripe that forms here. And if you look at the glacier on the left, you can see somewhere further uphill we had 2 other glaciers come together, and we have medial moraine. Now, when the glacier starts to melt, the meltwater forms an outwash plain, and we see a lot of depositional features here. Here you can see the lateral moraine, which was on the side of the glacier when before it had melted. Some other features, we get kettles. Kettles are where you have a chunk of ice that is surrounded by till, and as the ice melts, it fills in with the meltwater and forms kettle lakes. And you can see what that looks like in the picture there at the bottom. So the depression itself is called a kettle, and then if the meltwater hangs around, it forms a kettle lake. Other features that you might see, drumlins, which are these little hills of till that are formed in clusters. Here's an aerial view. They almost look like upside down canoes. And then here at the bottom, these are called erratics. So these are large boulders that were plucked by the glacier, and then when the glacier melted, they were just dropped off. So you can see they don't match the surrounding material. There's no other way for that boulder to have moved across the land. Here's a couple of pictures. I took these probably about 10 years ago. This is in Alaska. This glacier is about as tall as a 6-story building, and it's incredibly loud when you hear chunks of it break off. And that's what forms icebergs. Icebergs are freshwater because they are chunks of glaciers that have broken off into a larger body of water. There's me. These are just another view, and you can see the ice there at the bottom before it calves into the water, and then looking up at these alpine glaciers. This is called College Fjord. This is on the coast of Alaska. There's probably about 8, 9, or 10 different glaciers that are emptying into this fjord. Alright, so let's move on to our last type of erosion, which is due to gravity. We also call these mass movements, but it's just the movement of either rocks or even soil downslope due to gravity. So you can see we've got rocks here on the left and then soil here on the right. They can cause quite a bit of damage. Some of the things that trigger these mass movements, anytime you have heavy rain or rapid melting of snow, you're going to add a lot of water. That water soaks into the surface, it's heavy, and gravity is going to cause it to fall. If you have an oversteepened slope, so let's say that you've got waves hitting the base of a cliff, or you want to build a road, so you go in and blast on the side of the hill, that's going to weaken the slope and can cause falls or slides. If we remove vegetation, remember the roots bind the soil together, so we remove that, we're more likely to see weathering and erosion. If you have loose material or unconsolidated material and you have an earthquake, it can be jarred loose and cause landslides or mudslides. Alright, so the different types. If you just have rock fragments falling through the air, that is called a rockfall. It can be large or they can be small, but they tend to build up at the base of a hill. If you have a whole block of material along a flat surface, that's called a slide. So here you can see material that just slid straight down the hill. Here's another example. A slump is similar, except instead of moving down a flat surface, it has a curved surface. So this is a diagram that kind of shows you what it would look like from the side. It just slumps down. So here's a picture of what that would look like. And another. But you see that here, you can really see that curved surface where the soil just slumped downward. All right, a flow can be mud or it can be rocks, but basically if you have a lot of material that contain water, the water is going to pick up that sediment and it's going to flow just like a river. So mud flows are very fast. They can carry rocks, soil, water. It's almost like wet concrete, and then when it stops flowing, it hardens. Earth flows are a lot smaller, a lot slower. They carry more clay-sized sediments, but they too can, when they stop moving, they can harden and cause a lot of damage. Creep is when you have a very slow movement downhill of soil. So a lot of times what you'll see, if there are trees or power lines, you can see them curve or tilt downhill. You can see how the trees have tilted, but then they're still trying to grow up towards the sun, so you get that curve in their trunks. But it's very slow, so in order for that growth to happen, that has been over a very long period of time. Some of the things that we can do to prevent mass movements, building retaining walls if we are building roads in the side of mountains, if we oversteepen that slope, planting vegetation, putting bolts in the rocks, even fencing to protect from some of those rock falls. Building steps to help prevent erosion, diversion chutes so that if there are rock falls or soil creeps, they're going in a different direction. So there's just a few of the things that we could do there.